Welcome to part 3 of our Service Bus Management and Monitoring Reporting series. In this video, we will consider a real-world problem. How can we tell if a consumer of messages has ceased receiving messages and is possibly unhealthy? What if the system is otherwise functioning and responding and appears healthy? Health polling reports green. But perhaps due to a code change, a network issue, or an intervening firewall issue, messages are simply not being received at the expected service bus? Traditional health monitoring may be none the wiser. This is where Service Bus Management shines and can shine a light on your critical integrations. SBM provides the power for you to detect issues specific to your business based on any values present on your service bus messages. In this video, we will present 2 different kinds of reports designed to surface issues with message consumers. In this first example, let's categorize by exception message. We will query the dead letter queue for messages sent from the order processor system and which have a dead letter description containing JSON convert. This would indicate that the consuming system attempted to receive the message, however it failed to parse the message body. This may indicate the sending system has started sending messages the receiver has not been designed to handle, or it may reflect an issue in the receiver. Either way, this message has failed to be processed, and all messages like this will also fail. Let's enhance this report by adding a liveness check. We will express that we only want to count messages which meet these conditions provided they have been queued in the most recent 15 minutes. This ensures we don't count older messages. We only want to know if new messages are failing for this reason. In our introduction video, we demonstrated creating reports, so here is our pre-created report which meets this new definition. Order processor, new DLQ messages with JSON parse error. This report reads, find any message present on the dead letter queue where the message has a custom property called sending system with a value of order processor. Also, only count messages which were queued within the last 15 minutes. Finally, only count the message if it has a dead letter description containing the word JSON convert. This is an example only. You could craft a range of reports, one per known issue, along with a health rule for each with unique colors. In this way, you can easily identify issues as they arise. Alternatively, you could create a health rule which matches when any of your defined exception reports match and give this a high priority. The options are limitless. Let's consider a more general technique to count messages which are failing to be consumed. For this, we will create 2 reports. First, we will create the order processor, count of stale messages. Again, we will filter by custom property sending system and ensure it equals order processor. We will limit to messages queued more than 1 day ago. This will count messages from the order processor which were queued more than 24 hours prior to the report runtime. Let's now add a second report, order processor, count of new messages. These are similar, but they will provide different utility when used in a health report. Each report will be run twice, once against the main queue and once against the dead letter queue. This second report will allow our health report to check the count of new messages on the dead letter queue from the order processor system. The first report can be used in a health report to see the count of messages which are becoming stale on the main queue. That is, they have not yet been moved to the dead letter queue. Here are the new reports. In the first one, we are limiting to the messages from the order processor system that were queued more than 1 day ago. The second report counts new messages from the order processor. We have our reports configured. These will run every 15 minutes against both the main and the dead letter queues. Let's now make use of this new knowledge in a health report. We will configure a green health rule. This should express that if there were no more than 100 stale messages present from the order processor, and there are 0 new messages on the dead letter queue and 0 exceptions from the order processor, then the resource should be considered green. We will use look-back rules to consider only the most recent run. In other words, we will consider the queue and the consumer healthy when messages are not going to DLQ, there are no new exceptions, and we have an acceptable level of stale messages as defined by business. Now let's consider our amber rule. We will consider this a match if either there are more than 100 and less than 200 messages from the order processor system that have become stale, or we have up to 9 new messages sent to the dead letter queue. In either case, we must have no exceptions. If one or more message on the dead letter queue was due to our defined exception, then this rule would not match. Finally, let's consider our red alert. This will match if we have 200 or more stale messages on the main queue, or we have 10 or more on the dead letter queue, or we have at least one new message on the dead letter queue, which matches our exception check. This is an example only. It demonstrates you can craft reports which embody any level of complexity to match scenarios important to your business. Then, you can craft health rules using any combination of your report results and express your requirements using full logical expressions. And here are our health reports. Here is our green rule. We can see our 3 clauses all joined by the and conjunction, meaning all must be true for this rule to be true. And we can also see the first clause will query counts from the main queue, while the other clauses are running against counts of the dead letter queue. And here is our look back rule asserting to only consider the most recent run results. And here is our selected green color. Returning to the health rules. Let's select the amber rule. We can see it has the same 3 clauses as the green rule, however we use logical brackets to assert that only the first or the second clause needs to match for this rule to be a match. In either case, the exception clause must also match, and this rule is also limited to the most recent results. This query demonstrates the power and flexibility of the SBM reporting system. These 5 clauses embody the logic we saw earlier for the amber rule. We have 2 sets of value ranges, each in their own evaluation brackets and separated by an or clause. All 4 clauses are within a surrounding pair of brackets. The final exception clause is required and so is joined by an and clause. And here are those same 5 clauses expressed in an SBM health rule. We start with double brackets. The first pair of clauses must both be true, or the second pair must both be true. Provided one pair is true, we then evaluate the 5th and final clause. Now, let's select the red health rule. Here we see the same clauses, but in this case, if any one of these clauses is a match, then the rule will match. You don't technically need to refer to the same clauses in each health rule color, provided you achieve logical completeness. That is, try to configure your health rules such that every message will match at least one health color. If more than one health rule evaluates to true, the system will use the configured priority to select the winner. The health rule with priority closest to 1 will be considered the match. Let's wait for one run to complete, and in this time, we will send one message to this queue from the order processor system with our exception. Welcome back! And you can see our queue is the alert color. There are no stale messages. There is only one message on the DL queue. However, it has the exception we defined, and so the red rule matched as we defined. In this video, we have considered a common business issue and configured reports and health rules to match our complex business rules. We have observed our rules at work, and we can see at a glance the health of our Service Bus resource. Join us in the next video in this series when we will consider detecting aging messages on our Service Bus resources.